Hello sir, good morning. My name is Rehan Mokashi from TY IoT and serial number is 22. Today we are going to discuss what is transportation model role, and in that first we see northwest corner method. So first we will see what is transportation model. If there are some factories in different cities and they wants to supply the product to other cities. So here is a mathematical table. So here you can see there is a distribution center and demand center. Actually, what is the demand? Here is a plant 1, 2, 3. So you can consider first plant in Mumbai, another plant in second plant is in Delhi, and third plant in Chennai. And here is the supply. Supply you can consider 100 units from Mumbai and 200 for Delhi and 300 for Chennai. These are the units which we want to supply. So we are producing in this Mumbai, Delhi and Chennai. And in below that there is a demand. So demand is like B1, B2, B3 and B4. What is the demand of Mumbai? City 1, City 2, that like. In some cities there is a manufacturing unit and we have to supply that product from manufacturing unit to throughout the unit, throughout the country. And this X11, X22, there is a sample costs I have taken for the explanation of the concept. So if you want to transfer plant 1 to city 1, there is a cost is X11 you can consider. So how to solve this transportation model? So these are the steps. So first step is make transportation model. So already we have made one sample transportation mathematical model. Then find basic feasible solution, that is a IBFS. So when you are finding the basic feasible solution, we have many methods. So in that lecture we only focusing on the northwest corner method. Then another is perform optimal test, then iterate towards an optimal solution, and last one is check for optimality. And these are the methods for initial basic feasible solution. Methods are northwest corner method, which we are going to see, and then row minimum method, then column minimum method, and list cost method. These are the methods. And fifth one is a Waggle approximation method, but only we are in this lecture focusing on the northwest corner method. So let's see how we are solving the problem by using the northwest corner method. So here is the problem. Here is a, you can see origin which is destination, and supply is there and demand is there. I have already presented in a mathematical tabular formulation. So let's see how we solve the problem. So first is a O1 destination. So total supply from O1 destination is 5, and from O2 there is 8, and from O3 there is a 7, and from O4 there is a 14. So from demand from this D1, D1 from 7 is demand, and D2 from 9 is demand, and D3 from 18 is demand. And here you can see this 2, 7, 4, these are the values. Actually these are the cost. Means O1 needs to cost to supply a demand that type. So O1 needs to cost to supply. That's like O1 needs 7 cost to supply to D, and that type there is a you can see O3 needs 7 cost to supply to D3. That type means if you are supplying product O1 to D1, the cost is 2. Then we will see step by step how to solve this problem. The first step is to check the table is balanced or not. So how we will check these are balanced or not? For that we have to check supply is equal to demand is there or not. For check the balance, we will add 5, 8, 7 and 14 is equal to 7, 9, 18. So 5, 7, 8, 14 is equal to 34, and 7, 9, 18 is equal to 34. So both RHS and LHS values are same, means the table is balanced. Then now choose the method. So we are solving this problem by using the northwest corner method. So select this method to solve this problem. In that first step is check the table is balanced or not. If there is a not balanced, then we have to add the dummy row or dummy column. Then now we have to put the sides of the table. Sides means directions like north, west, south and east. So at the top side there is a north, and down side there is a south, and left side west, and right side east. We can put that sides. So we have to first put the allocation at the northwest corner. So in that cost matrix we have to give the allocation at the northwest corner. Mean there is a you can see north is here and west is here. In that corner which is the value that we have to put the allocation. So first we will give the allocation to the 2, because this cost is in the northwest corner. In that O1 supply is a 5 and D1 demand is a 7. So 5 is the supply and 7 is the demand. So we have only maximum supply is a 5. So we are writing a 5 in this and the remaining supply is a 0. So in that demand 7, the 5 demand has fulfilled and remaining demand is a 2. Then this O1 supply has fulfilled and there is a remaining value is 0. So we cancelling the row, because there is no any supply, so we will not give any next step, so we cross the line. Then coming to the second row, so when coming to the next row, there is a remaining demand is 2 and supply is a 8 and cost is a 3. So let's choose the from demand and supply which one is the minimum. Minimum is a 2, and now the demand one is a 0 and supply is remaining is a 6, which is 8 minus 2, there is a 6. Then there is a demand column is 0, so where cross the line on demand 1. Then check the other next corner, which is there is a cost is a 3 and the remaining supply is a 6 and demand is a 9. So in that demand and supply, which one select which one is the minimum value. The minimum value is 6. So let's we put 6 in that table. Then remaining supply there, then supply is fulfilled, then remaining supply is 0. Then 9 minus 6, there is a 3, so demand remaining is a 3. So supply is fulfilled, then we have to cross the line on this row. So in that remaining table there is a northwest corner is a 4. So supply for that cost is a 7 and demand is a 3, remaining demand is a 3. So in that check which one is the minimum value. So there is a minimum value is 3, so let's say put 3 in that table and minus with the 7. So the demand is fulfilled, so there is a 0, so we have to cross the line on this column. Then in remaining table there is a northwest corner is 7 cost is there. So for that 7 there is a supply is 4 and demand is 18. So in that minimum value is a 4, so let's we put 4 in that table. Then supply is fulfilled, so there is a 0. Then 18 minus 4, there is a 14. So the supply is fulfilled, then we need to cross the line. Then remaining is a 2 cost is there, and for that 2 remaining supply is a 14 and remaining cost is also, cost means demand is also 14. Then we will put the 14 in that table. Then 14 minus 14 is 0 and demand for also 14 minus 14 is equal to 0. Then we have to scratch remaining this table. Then we have to find the minimum cost in that table. So these are the values like 2, 3, 5, 1, 7, 3, 4, 6. These are the quantities, and we have put in this value, that is a 5, 2, 6, 3, 4, 14. That these are the cost. So we have to choose which one is the minimum cost. So for that calculation we have to select this quantity and cost and multiply this cost and quantity, and we have to calculate initial basic feasible solution. We need to calculate that initial basic feasible solution. How we calculate initial basic feasible solution? That is called IBFS. So we have 2 units with the cost of 5. So multiply that 2 into 5, that is the cost. We have supplied 3 with the 2, so multiply 3 into 2 plus multiply 3 into 6 plus 4 into 3 plus 7 into 4 plus 2 into 14. Here you can see initial feasible solution table. So let's find minimum transportation cost. Here you can see 3 into 5 plus 2 into 3, 6 into 3, 3 into 4, 4 into 7 and 14 into 2. So values are 10 plus 6 plus 18 plus 12 plus 28 plus 28 is equal to 102. So the cost is 102 for this transportation table by using the northwest corner method. Thank you.